Welcome everyone to this lecture on exploratory data analysis, where you would be learning the basic methods for doing an exploratory data analysis for a given data set. So this falls in the subject area of statistics, where statistics involves data collection, the methods for data collection, and then the methods for data analysis, under which we are learning the first part or the beginning of a data analysis, that is a descriptive analysis or else exploratory data analysis, for which you would be learning graphical methods and also numerical methods to do a proper basic descriptive analysis. After doing those analysis, that is after obtaining those results like graphs and numerical summary statistics, you can interpret and make decisions based on the results that you obtain for the descriptive analysis. So before that, let us just have an idea what type of data are available in a data set. Mainly, the data can be divided into two types. When the data is numerical, we call them as quantitative data or numerical data. For example, variables like monthly income, age, EZ score, exam marks are examples for quantitative or numerical data. That is this part, right? Then we have in our data, we might be collecting people's marital status, the religion, the job that they are doing, and the sector that they are working in. Likewise, we are collecting non-numerical data or qualitative data that falls under qualitative or categorical data, right? So in a data set, or when you collect some data about people, human, animals, or any other entities, all the variables would either fall into quantitative or qualitative types. So first, we would learn methods for analyzing quantitative data, that is numerical data, where the data collected is numbers. For example, let us consider you collected the exam marks of the students in your class. So you would have quite a big lot of numbers like this. So can you get an idea about the students' performance just by looking at these raw numbers? You can't even see what is the most common mark, the lowest mark. That also is hard to identify from this raw mark. This is called as raw data, or the data that we collected as it is. So to get an idea, to get a decision from this data, we need to analyze. So that's what we are going to learn. For example, you would be interested in to know the highest or the lowest mark, who is the top mark in the class, and on average, how was the student's performance, or else you might be want to know what is the cutoff mark of the top 25% of the class. So these are kind of decisions or insights that you would like to get from this data. So in statistics, we have respective summary statistics or numerical statistics that would give you results for getting these decisions. As in, when you want to know the highest and the lowest, you will look for the minimum and the maximum or the range of the data. And when you want to know the average, you are looking for the average or the mean of a data set. And when you want to know the top 25% of value, you are looking for the third quartile. So we would be learning these things in detail in the coming slides. So these numerical statistics or summary statistics for quantitative data mainly or falls into different aspects. Like first aspect is where we would be looking at the center of the data. You call them as measurements of central tendency. So along with that, the first measurement of central tendency you are going to learn are mode, median, and mean, or 3 M's, right? So the mode is the most frequent value of a data set. For example, if I ask what is the most frequent shoe size in the class, so I have to collect the shoe sizes of the students in the class and see which shoe size is corresponding to many of the students. The median is the middle point of a sorted list of data. That is, when you sort it ascending or descending order, which value falls in the middle. And average is the addition of all the numbers and then dividing by the number of values you have. So that's how you calculate mean. So these are the main measurements of central tendency that you are going to learn. So about the center or measurements of center, let's say these are the marks of 10 students, right? Then if you want to know what is the most frequent mark, that is the mode, because 30 is there 3 times, so it becomes the mode, the most frequent value. Then average mark, what you would do is you will add up all these values and divide by 10 because there are 10 students, right? So you get the average performance of the students as 35.6. Then median data, so you have to order them. It is not ordered here, so you first order the data and then check for the midpoint, right? So since it is 10 data points, 5 values to this side and 5 values to this side makes the center. So to calculate the median, you have to add up these two middle values and get the divide by 2, right? So that becomes the median. So for the completeness, I have given the formulas also. So when you want to find the mean, specifically the arithmetic mean, which is the mean that you calculate by adding the values and dividing by the number of values. So that's called mean. And to talk about more about the mean, get these two examples. Let's say these are the ages of kids at a nursery, and this is the ages of kids at another nursery, let's say, right? Suppose you calculate mean for both the data. See, its mean is 3.22 here, but here mean is 4.1. So mean is quite large here. So what was the reason for this large mean? Was this there had been some unusual value in this data set. Otherwise, all the rest of the values are same across both the examples. So mean got inflated or got a high value because of this one high value, right? So this can be a special observation which you have to consider for the second example, right? So this mean has this issue that it is affected by these extreme values. Suppose this was incorrectly entered data, or whether this is a kid staying in the daycare center, not in the nursery, but have been collected into the data set. So likewise, mean is affected by these extreme values. So let us see the median, which is the midpoint of a sorted data set. So if there are odd number of observation, we can specifically get the median as the n+1 divided by 2, the value of the sorted data set, right? But if you have even number of data, as in the previous example, median will be the mean of the two values. That is, you add up the two middle values and divide by 2. So for example, here in the first one, we have odd number of students, so we get 4 values here, 4 values to this side because there are 9 observations. So we have the middle as the n+1 divided by 2 value. And then in the second example, median, we have 10 students here. So median will be the average or the mean of the two middle values. So which would be values as this. See here, median is 3 here, median is 3.25 here. So median is not that affected as the mean was affected by this observation because it lies in the corner in the ordered data set. It is the middle point that we consider in the median, right? So that's a plus point of median when you compare with mean. And then about the mode, which is the most frequent value. So in some data you would have only one mode because 5 is has a frequency of 3, so mode is 5. But when you take this here, this data set here, 6 is mentioned 2 times and 5 is there 2 times. So there are 2 modes, right? Likewise, there can be many modes in a data set. So that's called multi-mode. And one mode, multi-mode. And this one, none of the observations were mentioned or recorded more than once. So there's no mode in this data. So those are features of a mode. That is, it can either exist or not, and also it can have more than one value. Right. Then together with this, let us talk about some drawback or a limitation of this mean, because mean is a very prominent or very commonly used measurements of center. Right. So consider these 3 examples. Let's say these are the marks obtained for 3 different subjects by 5 students. Right. So if you consider only the mean is same for all the subjects. So if you use the mean as a measurement to comment about the students' performances, you would say the students are equally performing across the 3 subjects. But when you look at the data, it is not true, because in this subject, only 2 students have performed well, whereas the other students have got very low mark. But in the second subject, the performance is almost similar across everyone, and exactly similar performance with all the students. But here, there's a little deviation, but there's high deviation among the students. So in addition to the mean, we can look at data in terms of the range that the data takes, right? So for these 3 examples, even though their means are same, the range will be totally different. So we are extending our analysis to incorporate measurements of spread as well, or you call them as measurements of dispersion. A simplest measurement for talking about the spread of the data is the range, that is the difference between the minimum and the maximum of the data. And then we can calculate the quartiles, that is in an ordered data set, the values, the 3 values which divide the data set into 4 equal parts, they are called quartiles. So it gives an idea of the whole range of the data, not just only the center of the data. So these are this is how you compare the measurements of spread versus measurements of center, because in the center we look at one value which speak about the most typical value or the center of the data. And there's another measurement called variance or the standard deviation, which measure the dispersion. Dispersion means distance, discrepancy, how far the data lies from the mean. That's been calculated as variance, where all these things you will be learning in detail in the coming slides. First, let us talk about the quartiles. So as I said, the quartiles divided the data into 4 equal parts. So to divide a data sequence into 4 equal parts, you need 3 measurements or 3 locations. You name these locations as first quartile, second quartile and the third quartile, right? So I have given the formulas to find the location, right? So you can refer them, but in simple terms, you will look for the equally distant 3 locations to divide the data set into 4 parts. Right. Let us see here. Suppose this is the data set you want and that is ordered as well. So make sure for quartiles you have to order the data, right? So you have to order the data. So that is the middle of the data, and first quartile is the middle point of the lower half, and the second quartile will be the lower half of the upper part of the data. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18 data points are there, right? So 18 data points, right? 1, 2, 3, 4, 5, 6, 7, 8, 3, 5, 8, 8, 8, 6, 16, 17 data points are there. So you have, it is an odd number. So you have a specific median, which is the midpoint, and when you want to get the first quartile, you look for the midpoint of the first half, right? And for the third quartile, you look for the midpoint of the upper half, right? So it would be 7 plus 8 divided by 2, and here it would be 20 plus 23 divided by 2, right? So some of these formulas given previously, that is n plus 1 divided by 4, n plus 1 divided by 4 multiplied by 3 will not correctly work for small data set, right? So that also I have to mention. You would say the formulas are not, notice that formulas are not exactly correct for very small data set, because dividing into 4 equal parts would be a little difficult when you have small data set. But statistic is developed for handling moderately or sufficiently large number of data, because when you have if you have only 1 or 2 observations, you don't need to analyze, because you can see exact whole picture of the data can be seen from the raw data as it is, right? So Q2 means the second quartile is the median, which is the midpoint, right? Then I said the last measurement for measuring the spread or the dispersion is variance, where it consider the distance of each observation from the mean. So in the x bar is the term or the notation that we use to represent the mean of a data set, right? So we have the data like this, x1, x2 up to, let's say we have 10 data points, right? Some 10 values, and for these data we have a x bar, which is the mean. So we consider what is the distance of each of this observation from the mean, right? So we calculate it as xi minus x bar. So that's the raw distance, right? But when you consider the raw distance and when you take the average of the raw distance, sometimes, not sometimes, the negatives and positives get cancelled off and the variance would come as 0, right? So whether it is greater than the mean or the less than the mean, we are giving the same quantity as the distance by squaring, right? So if it is 2 units high above the mean or 2 units below the mean, it has the same quantification or same magnitude with respect to the distance. So it is not the raw distance we consider the squared distance, right? So if this is 3, 4 and if the mean is 5, 3 minus 5 squared is the squared distance. So likewise for each of the observation, you calculate that squared distance and add up them and divide by the number of observations to get the mean of the data set. So this is a kind of another formula which can be derived from this. When you expand this formula, you can come up to this. So that for this can be used for manual calculation, because rather than doing this calculation, adding up the x squared and dividing by n and subtracting the squared of the mean would be sometimes easy for manual calculation. So this is for group data. That is that I will not talk much, because it becomes useful when you have group data, right? So just to highlight the importance of variance to tell how nicely the variance capture the spread of the data, consider this example that I mentioned before, right? So all these three data sets have the same mean, but when you calculate the variance, you will notice that their variances are quite different. For example, the first subject has a variance of 2 and the second subject there's no variance. Variance is 0. And this one, where there was a large difference among the students' performance, because it's only 2 students performing top class and the rest of the 3 students were having a very low performance, right? So the variance was so high, which was at 25.5. So you also can substitute these values into the formula and try to get these values, right? So this variance correctly tell us that there's a difference among the behavior of the students across these 3 subjects, right? For example, in the second subject, almost all the students are equally performing, so the variance is 0. And for the first subject, variance is 2. That means there's a mild difference. But for the third subject, there's a large difference among the students' performance. So this example highlights you in an exploratory data analysis, you should consider all these aspects, that is measurements of center and measurements of spread as well. Right. So with that, I end up the story or the techniques for analyzing numerical methods for or quantitative data analysis, that is measurements of center and measurements of spread. With that, we are moving on to methods for analyzing qualitative or categorical data, where the data is not numbers. When the data is numbers, the first thing that we can do is creating tables for the data that falls into the categorical variable. For example, if you have collected data about the district of a person living in, and we can count how many, or if you have collected the number of national schools in different districts, you can count how many schools are there in each district and make a table giving the counts. Or else you can extend this to give the percentages as well. And extending this more further, when you have two categorical variables, you can form up two-way tables. Or when you want multiple categorical variables, you can go for multi-way tables as well. So in the second table, we want to compare education levels with the gender of the people, right? That is just to see whether many females have had a primary education or a degree. Likewise, you want to make a comparison between these two variables, or you want to see the summary values or summary statistics falling across these two-way table. So you can do by making a cross tabulation with the two categorical variables as given here. That is the story about making tables. The next step is making graphs for categorical data. The simplest type of a chart or a graph that we can draw for categorical data is a simple bar chart, which is based on data of one categorical variable. For example, as given here, if we have considered the age group of the visitors coming into this is to the visitors coming into a zoo, and how many children are coming within a day, how many adults, middle-aged people, senior citizens. So this bar chart displays the percentage of each age category, but you can obviously draw it for counts as well. So a bar chart can either be drawn for count or the percentage belonging into or falling into each category. So we have done one type of a chart for categorical data. So this is how the data would come to you. These are the classes of some graduates: first class, second upper, second lower, general, and likewise. So you would initially be counting how many are having first classes, second uppers, and so on, and then you can get the percentages out of the total. And then you can put the same information into a bar chart as well. So here I have taken it for counts, but you can take it for percentages even. Then about the ordering of the values in the x-axis, right? So you can see here I have started with first class, second upper, and like in not in the alphabetical order, right? That is because when the categorical variable is having an ordered nature, so we will be preserving the same in the slides as in the. When you have two categorical variables to compare, you can draw a component bar chart where the bars corresponding to one categorical variable is divided into component parts according to the other categorical variable. For example, we initially draw a simple bar chart for the class of the graduates. So we had a one whole bar for each class, and now we can divide that class or the counts falling into each class, first class, second upper, and so on, as per the gender of the student as well. So the display will be like this, where for first class we have a total of 15 students, out of which how many are males, how many are females. Likewise, we can draw the component bar chart. You can see how the counts of each color, each gender is changing across different class levels. The same information or same display can be put up as a multiple bar chart as well, where instead of dividing a single bar into component parts, we are taking multiple bars adjacent together to represent the different parts of the other second categorical variable. For example, here first class, you have a separate bar for males and for females separately, so that you can compare and see how the counts are changing. But when it comes to comparison purposes, comparing with counts is not good if the total counts are different across the class levels, which is obviously the case in this example as well. We have about 20 plus classes, second uppers, some more, likewise different counts. So comparing the male female behavior with counts is not good when the total counts are different. So in a situation, we can use the percentages falling to different gender levels within each class category and see whether the percentages are high in one gender level than the other, to make a comment like whether the gender of a person, gender of a graduate is associated with the performance. So we calculate the percentages here row wise, that is within each class level, what percentages is females or males. But you can do it in the other way also. Think which one is the better. Right? This might not be the best way for all the situations. So this information can be taken up into a graph like that, giving the percentages falling into each gender level across different class levels. So in here, rather than comparing with the counts, the comparisons are better because we have now the percentages. So you can see the percentage of the red color is increasing. That is, male percentages are increasing when the level of the class decreases. That means in the other way around, females are doing better than males when you consider their percentages. So likewise, if after making a graph, after drawing a graph, you have to comment and you have to make an interpretation as to what this graph is telling you about the association between these two variables. For single categorical variable, in addition to bar charts, you can draw pie charts as well. Say for example, we have the data about export figures in 1993 with respect to the type of the exports: agriculture, industrial, mineral, and so on. And with respect to these export figures in rupees, you can get the percentage of export amounts that was obtained from each type in as like this, as a percentage, because in a pie chart we display it in terms of the percentages. So we, rather than with that table, this pie chart will quickly tell you that this red color is dominant or very big with respect to the other slices. This slice is so big. That means the agriculture exports have been very prominently larger than that of other exports. So this also a 3D pie chart for the same data. This is the pie chart that we can draw for the bar chart that we drew in the first few slides for simple bar chart, where you draw separate bars for each class level, how many first classes, how many second uppers. So now we here divide the circle into component parts depending on the percentage belonging into each category. So when it comes to practical situation, since both pie chart and bar charts are suitable for categorical data, you would come up with a question which graph is preferred. That is whether to use a pie chart or a bar chart. So there's no rule that you have to go for a bar chart or pie chart, but it depends on the situation. When it is a response like this, a ordered response, right, where there's a ordering in the categories, rather than a circle, a bar chart is better so that you can preserve the ordering of the categorical variable as well. And at the same time, if you have too many categories, then like more than 5-6 categories, having too many colors on the same circle also is not acceptable, because too many slices will not give you a quick understanding from the pie chart. So the kind of rule of thumb is usually 5 to 6 colors or 5 to 6 categories in the categorical variables are acceptable for a pie chart. And also when there's a ordering in the categorical variable, a bar chart is better. So those are the basic charts for qualitative data or categorical data. Namely, we learned bar charts and pie charts, and when we want to compare two categorical variables or as two qualitative variables, we went for component bar charts and multiple bar charts. Also, you can draw percentage component bar charts as well. Then next part of an analysis, we might come across variables which are quantitative. We initially learn measurements of center and measurements of spread like mean, median, mode, variance, quartiles, minimum and maximum. Those are the numerical methods for quantitative data. Now we are moving on to graphical methods for quantitative data. Some of the quantitative data can be time related, as in you might have the income across each years. So such time related data can be displayed as a time chart or a line chart, where we connect the dots of corresponding values for the y variable across each year. So why we are connecting is because this x-axis is connected as the calendar period. So we can see whether it is increasing, decreasing or remaining same across the years, across the timeline. So this graph we only draw for time related data, or when the x-axis has some relationship. Don't draw line charts for income of different districts or different companies. There's no basis for connecting this company to the other, or which is the basis for taking company A and B together. But 2011 should always come after 2010. So there's a dependency across the values of the x variable. So that's why we are connecting across that order as well. Otherwise, if you draw it for categorical variables which does not have a time relationship, it can change the line that comes up with the order that you have maintained. But anyone has to maintain this order when it is a time related variable. Then commonly for any quantitative variable, not necessarily they are time related data, you can calculate or you can make a display of the counts falling into different classes of the quantitative variable. We call it as a frequency distribution. So it's kind of a table that we make up for the quantitative variable, right? We have the class and the frequency. We use the letter F for frequency. So we divide the whole quantitative variable into different classes and count how many observations are falling into each class. So namely, the steps to create a frequency distribution would be, when you have a data set, find the minimum and the maximum and decide how many classes you are going, 5 classes, 6 classes, or 10 classes likewise. So there's no rule, but we can do it with trial and error. That is, you make a frequency distribution with some number of classes. If it is not a good display coming up, you change the number of classes and redraw. So likewise, this number of classes is not a rule, but don't go for too many classes. Also, don't have too few classes as well, so that you will not see a good display of the data. Then once you decide the number of classes, calculate the class width and arrange the class intervals, that is, put up the class intervals 2 to 4, 4 to 6 likewise, and calculate the frequency belonging into each. So these are roughly the steps in creating a frequency distribution, starting with deciding the number of classes, having the class intervals, usually between 5 to 15 classes, but these are also not fixed rules. But we have to be careful that we don't create classes in a way that they overlap, right? So one observation will fall into exactly one class. So suppose the L is the lowest and smallest value, and L is the largest value in the data, and K is the number of classes. So you can calculate the width of a class like this. Suppose this is an example giving the ages of 10 students in a class, right? So if you select the number of classes to be 4, so 25.3 minus 18.1 and divide by 4, it's 1.2. So it's roughly like 2. So you will have class intervals like 18 to 20, 20 to 22, 22 to 24, 24 to 20. So since we have 20 in both class, so you have to correctly specify to which class the boundary values belonging into, right? So here 20 belongs to this interval, right? And this is how you obtain this, and then you count how many are between 80 to 20, 20 to 22, like. So this table is called the frequency distribution, where you display the frequencies falling into each class interval together with the relative frequencies or the percentages as well. After creating a frequency distribution, you can extend your graphical representation to a histogram, where histogram display the same information that you gave in the frequency distribution table. So for each class intervals, you will be creating separate bars which are adjacent to each other because they are connected, and display the count or the frequency falling into each class. Right? But same as in the frequency distribution table, you can give the histogram in terms of the relative frequency or the percentage as well. So this is the first graph that we learned for quantitative data, that is histogram. After that, we can think of how to extend our graphical analysis for association between two variables, necessarily for two quantitative variables. Suppose you want to know how the years of experience and the monthly income is associated, how the age of a person is associated with the salary he got. So in any of these scenarios, that is, you have pairs of variables that you want to check for their association, you can distinguish one variable as the independent variable and the other as the dependent variable. But in some scenarios, there might not be clear distinction between independent and dependent variable. That is X variable and the Y variable you might be familiar with. So here, the decision whether it is an independent variable or a dependent variable is taken by considering whether that variable depends on another variable. So if a particular variable does not depend on something else, for example, age of a person will not depend on something else. So you call them as independent variables. But the monthly income or the bonus that an employee get will depend on other characteristics. For example, the number of service years and the type of the job that person is doing. So it is depending on other variables. So you call them as dependent variables. Consider a situation we have two quantitative variables where you identify one variable as the independent and the other as the dependent variable, and you are interested in the association between these two variables. The graph that you can draw for this kind of a situation is a scatter plot where you plot the values of the x and y variable in a coordinate axis, coordinate plane. So by looking at the plotted points, you can comment whether these two variables are associated or not. If they are associated, what type of association they have. For example, you can see here when the years of experience are increasing, the monthly income is also increasing. So you would say there's a positive association between these two variables. Some common types of associations that you can examine in scatter plots are when you can approximate a trend line like this on the scattered line. You can say there's a linear positive association because the points are falling in a linear pattern. For example, if the plotted points are like here, here, here. So the lines, the points are can be approximated as a line. So it's a positive line. When x is increasing, y is also increasing. Here also there's association. When x is increasing, y is decreasing. Points are falling like this. Then you say there's a linear negative association. But you can see in these two examples, they are related. You can see, you can smoothly draw a curve across the points, but they are not linear relationship. But whatever the association that is held between these two variables can be examined by making a scatter plot like this, whether it is linear or non-linear. So if there's no relationship, the points will be falling randomly scattered, not in an increasing or a decreasing pattern. Right? So then you would say there's no relationship. When you take x and y variables, if the points are falling randomly here and there, kind of like between two horizontal lines, you say there's no relationship. But when you see an increasing or a decreasing trend or a curve pattern, you say there's a relationship. But if that pattern is a line, you say it's a linear relationship. So some probable displays that you would get for scatter plots are like this. So this is a strong negative association, a positive association. So this also positive but not that strong as here because there's a larger variability across the points. But this is a very strong negative association. This is a mild negative association. These ones are more or less like no association. Right? In summary, under exploratory data analysis method, we learned both graphical methods and numerical methods. So we learned graph for single categorical variable, namely bar charts and pie chart. And for single quantitative variables, you learned about histogram. And for two categorical variables, you learned how to draw multiple bar charts, component bar charts, and percentage component bar charts. And when you want to compare two quantitative variables graphically, you can draw scatter plots. Together with these graphical methods, we learned numerical summary statistics as well, namely the measurements of center like mean, median, mode, and then measurements of spread like minimum, maximum, quartiles, namely the first quartile, second quartile, third quartile. And then we learned how to calculate the variance as a measure of spread as well. So in summary, using these basic methods of descriptive analysis, basic methods of exploratory data analysis, you can perform exploratory data analysis for a given data set.